Okay, so we're given that the life x in hours of a battery is the constant is sorry of a battery in constant use is a random variable with exponential density. What is the probability that the battery will last more than 12 hours if the average life is 8 hours? Okay, so let's extract some information from this, right? So we have a random variable x, right? And we're given that it is exponential density. So let's just write down what exponential density would look like, which is p of x equals 1 over r e minus x over r. So this is the form of exponential density. This is the equation for exponential density with a mean r. Okay, so r equals the mean. Okay, and in this case, the so, also known as the average, right? Okay, so in this case, r equals 8. Okay, so we're given that here, right? Okay, so this p of x becomes p of x is 1 over 8 e to the minus x over 8, right? Okay, so that's our probability density function. Okay, and so next we need to remember that for any function, okay, so for any function defined over some interval, okay, so let's just say, so we have this, right? Oops. So we have this, so that's our function that we're concerned with. So now we also know that for any function, know that for any function defined over some interval j, the probability that x takes a value in the interval is given by the integral, and for this domain we know that the probability is going to be 1. Okay, so essentially what this is saying is that if x is defined over j, then the probability that x takes some value in that interval is certain, right? And remember, probabilities go between 0 and 1, right? So now we know that, so given that's the case, right? So we need to figure out what this interval is, right? So what is j? So what is j? Okay, so we've been told that what is the probability that the battery will last more than 12 hours? Okay, so j in this case, j will be, so j is gonna be between, so j is that x is greater than or equal to 12, right? So just read that. So x is greater than or equal to 12. Okay, so anything above 12, so essentially x goes from 12 to infinity, right? The probability that the battery will last more than 12 hours. So what we need is the integral from 12 to infinity of p of x, which is this, what we have over here is 1 over 8 e to the minus x over 8 dx, right? So that's what we're looking for, right? So how we know this interval is because we've been asked for, what we're interested in is finding out what the probability of this battery, what the probability is of this battery lasting more than 12 hours, right? More than 12 hours, so anywhere above 12, so which is essentially infinity, right? And this is basically giving us the area under the curve of this function. Okay, so now we can just go ahead and solve this, right? So we can just pull this 1 over 8 out. This is going to be equals to 1 over 8 integral from 12 to infinity of e to the minus x over 8 dx. And to solve this, let's go ahead and use substitution. So let u equals minus x over 8. So du by dx equals 1 over 8 times minus 1, right? The derivative of x is minus 1. And du equals minus 1 over 8 dx. And we only have a dx up here, so multiply both sides by minus 8. So minus 8 du equals dx. Okay, and now we have everything we need to substitute this in. So we're going to say 1 over 8 times the integral from 12 to infinity of e to the u dx is this, so minus 8 du, right? Now technically these bounds are not correct for this function u, right? Because this variable u, because these are for x, but we will bring them back shortly after we do this integration. So we can pull this minus 8 out again, right? So I'm just going to draw a line. So this is minus 8 over 8 integral from 12 to infinity of e to the u du. And this is straightforward. We know the integral of e to the u is just e to the u, and this is going to be minus 1. So this is just minus 1 e to the u minus 1 times e to the u evaluated between 12 and infinity. Okay, of course we can't do this, right? So we need to bring the x's back in. So this is going to be minus e, so substitute u for what, so u is minus x over 8. Now we can evaluate that at 12 and infinity. Okay, right, so I'm just gonna bring this up here. Okay, so this is essentially asking us, we can't just plug in infinity, right? So essentially what this is asking us is the limit of minus e minus x over 8 as x approaches infinity. Okay, so as x goes, so this is the same as, so this function is the same as 1 over, so minus 1 over e to the x over 8, right? And as this goes to infinity, infinity divided by 8 is still infinity, right? So this is going to be smaller and smaller, so this is going to go to 0. Okay, so what we have is, so we need to, so that's the upper bound, what we get. So we have, so that's the upper bound, right? So and we finally have, this is equal to, so the upper bound of 0 minus e to the minus 12 over 8. Okay, so that's, right? So this is just gonna be 1 over 0 minus 1 over e. So we can simplify this. So this is just going to be 3 over e to the power of 3 over 2. 4 times 3 and 4 times 2, right? Just simplifying it. So this is just going to be 1 over e to the power of 3 over 2, and that's 0.233 approximately. Okay, and that is our answer. So the probability the probability that x is greater than or equal to 12 equals 0.233. Okay, so this should be 0.223.